Alright, in this video I'm continuing to work through a 6-part question involving recursive formulas, geometric series and mathematical induction with spreadsheets tacked on the end. I'm up to part 4 of this 6-part question, so if you haven't already and you need to, I'll put links to parts 1, 2 and 3 so that you can take a look. For this part 4 we're told to write an expression for fn by adding the one remaining term of fn to the sum of the series found in part 3 and then replace f0 with its value, which we were told at the beginning f0 is equal to 20. So far in parts 1, 2 and 3 we've just left it as f0, we haven't evaluated it, but here we're getting to the time where we do. So basically this part 4 is asking us to combine what we worked out in part 2 and part 3. So for part 2 we found this expression of a term 4 to the n f0 minus a gp, and in part 3 we evaluated the sum of this gp, so that now in part 4 we're just putting them together. So what I might do is I'll turn over, and for this part 4 we know that f of n will be equal to, firstly, the 4 to the n f0. So 4 to the power of n times f0 minus, and then instead of writing out this whole sequence, we can now just write out its sum, which is 4 to the n minus 1 on 3. So that'll be minus 4 to the n minus 1 all divided by 3. And we can probably clean this up a little bit. So I'll get a common denominator. So it'll be 3 times 4 to the n f0 minus 4 to the n minus 1 all divided by 3. And then from there, because we know we're going to put f0 equals 20, we might as well just do that now. So 3 times 20 would be 60 times 4 to the power of n minus 4 to the power of n minus minus 1 would give us plus 1 all divided by 3. And then we could probably just combine this 60 times 4 to the n minus 1 times 4 to the n would give us 59 times 4 to the n. And then we've got our plus 1. And then we divide that by 3. And there's probably not much more we can do there. So that's it. That's our expression of f to the n, f of n. Is 59 times 4 to the power of n plus 1 all divided by 3. So what we can see here is in these first 4 parts we've gone from a recursive definition of this function where we're told f0, the starting point, and then how f of n relates to its prior value. And by noticing a pattern and doing a bit of mathematics, particularly with our geometric series, or sometimes called a geometric progression, we've then converted that recursive format into what we call a closed format, where instead of f of n referring to the prior value, now we've just got f of n in terms of n. And we can substitute any n in there and we'll get the value without having to work through what were all the prior values. So I think that's the essence of where we've been heading up to this part 4. So that's it for this video. Hopefully it's all made sense. And what I'll do in the next video is I'll take a look at part 5. All right, tick boom.